This problem is about finding the surface of revolution determined by the parametric equations x is equal to 5 cosine theta, y is equal to 5 sine theta over the interval 0 to pi over 2 about the y-axis. It may be good to graph this and see what we're going to do here. So because the angles are from 0 to pi over 2, we just go from 0 to pi over 2 here. Okay? So when x is 0, cosine 0 is 1. 1 times 5 is 5. So there you go. And sine would be 0. 0 times 5 is 0. So at theta equals 0, the point is right here. Now let's look at pi over 2. Cosine pi over 2 is 0. 0 times 5 is 0. But sine pi over 2 is 1. 1 times 5 is 5. So the point is right here. And the orientation of the curve is counterclockwise. We want to revolve this curve about the y-axis. So the graph should be something like this. And then we want to find the area of the surface. Now using our formula here, it says 2 pi from 0 to pi over 2 because we are revolving about the, we're supposed to revolve about the y-axis, so the graph should be like this. Okay, there you go. So in this case, the radius is given by this. That's the radius, okay? And that is determined by your x of t. So that's going to be 5 cosine of theta times the square root of the derivative of x with respect to theta. Let's do that one here. X prime is negative 5 sine theta, and the derivative of y with respect to theta is 5 cosine theta. So that's what we will put here. dx d theta is negative 5 sine theta squared, and dy d theta is 5 cosine theta squared d theta. Simplifying our integral, this part here will become 25 times cosine squared theta plus sine squared theta. So cosine squared and sine squared, we factor out 25. That will simplify to just 5. Because cosine squared theta plus sine squared theta is 1, the square root of 25 is 5. So multiplying that with 5 cosine theta, and our d theta is here. So we get the integral from 0 to pi over 2 of 5 cosine theta times 5 d theta times 2 pi. We can pull this constant out. That's 25 times 2 is 50 pi. And the integral of cosine is sine. We evaluate that from 0 to pi over 2. Well, sine pi over 2 is 1, but sine 0 is 0. So this will give us simply 50 pi. So that's the surface of revolution determined by this curve. We can actually do this without resorting to calculus. We know that the surface area by sphere is 4 pi r squared. That's the surface area of a sphere. But because this is just a hemisphere, we can divide by 2. So we should get 2 pi r squared. Now the radius is equal to 5. So this will give us 2 pi times 5 squared, which will give us the same answer as 50 pi. So there you go. Using calculus, using the formula to find the surface area of a sphere.